Let's write the general form of quadratic polynomial. It's ax squared plus bx plus c. And we have to factorize the polynomial x squared plus 3x plus 2. Since this polynomial cannot be factorized using any of the identities, we use a different technique in which we split the middle term. Let's see how. Comparing this polynomial with this one, we can say that a equals 1, b equals 3, and c equals 2. To factorize such polynomials, there are only two things you need to know. First, the coefficient of the middle term, that is 3 here, should be written as the sum of two numbers. Something like x squared plus n1 plus n2 x plus 2. n1 and n2 are the two numbers. This was the first thing we had to know. But is it equal to the sum of any two numbers? No, that's where the second thing comes into the picture. The numbers should be such that n1 times n2 equals a multiplied by c. A is the coefficient of x squared and c is the constant term. Here a is 1 and c is 2. Hence this will equal 1 multiplied by 2, which equals 2. Now we have two conditions. First, n1 plus n2 equals 3 and n1 times n2 is 2. Can you think of two such numbers which satisfy both these equations? Yes, they are 1 and 2. 3 can be written as 1 plus 2 and the product of 1 and 2 equals 2. n1 is 1 and n2 is 2. Let's verify it again. n1 plus n2 is 1 plus 2, which equals 3. And n1 times n2 is 1 multiplied by 2, which is 2. So we cut the sum as 3 and the product as 2. So we write 3 as the sum of these two numbers. This was the only part of the video that you need to understand really well. All we have to do is get these two numbers. The rest of the part is straightforward. So we write this polynomial as x squared plus 1 plus 2 multiplied by x plus 2. All we did here was split the coefficient of the middle term. Now we expand the brackets using distributive property. So we write it as x squared plus x plus 2x plus 2. Here we just expanded this. Now what do? Can we factorize this by grouping terms? Yes, we can. We write this as x squared plus x in brackets plus 2x plus 2 in brackets. This step is called grouping. In the first two terms, we have x as a common variable, so we write it as x multiplied by x plus 1. In the second group, we have the number 2 common and we write it as 2 multiplied by x plus 1. Now it is clear that the binomial x plus 1 is common to both the terms. So we write x plus 1 here and multiplied by x plus 2. This reduces our final expression to x plus 1 multiplied by x plus 2. The most important part of this technique is writing the coefficient of the middle term as the sum of these two numbers. These steps should come across relatively easy as you have already solved problems based on grouping. If not, it may be a good idea to watch some of those problems being solved again. It will definitely help.